Hey everyone! In this video, we're going to be taking a look at a couple examples where we need to use the power rule for functions, but now we're going to be doing that with rational exponents. So to start off with, let's just remind ourselves of the power rule and how we adjust that for functions. So if I have an expression x to the n power, remember the power rule, if I take the derivative of this, the exponent comes down out front, and then we subtract 1 away from the exponent. And now this works with any rational exponent as well. So our exponent can also be fractions. And the way that we adjust this for when we're talking about a function, we need to apply the chain rule. So now let's say I'm taking the derivative of a function, and we'll call it u of x. And this function is raised to some power. And I'm going to say that that power is r, just because that can stand for rational. Now, applying our power rule for functions, the exponent comes down out front. So we have r times our function u of x. And then we do subtract 1 away from the exponent. But now applying the chain rule, we also need to multiply by the derivative of the inside. So then we'll multiply by u prime of x. And as I said, this works for any exponent. So our exponent can be a whole number, an integer, or it can be a fraction as well. So now that we know that, let's use it in a couple examples. My first example, I want to take the derivative of x cubed minus 2x plus 1, and this is raised to the 5/3 power. So to take the derivative, we'll use our power rule for functions. So first thing, the exponent will come down out front, so we have 5/3. And then we're going to multiply this by our function. And then we're going to subtract 1 away from the exponent. So 5/3 minus 1, that's going to leave me with the 2/3 power. But now, like I said, we need to apply the chain rule. So here we're going to multiply by the derivative of the inside. So the derivative of x cubed minus 2x plus 1, this is just a regular polynomial, so we can apply our power rule. So the derivative of x cubed, we have 3x squared. And the derivative of negative 2x, we're left with negative 2. The derivative of 1 is just 0, so that will go away. And there's our derivative. So if I wanted to, maybe I would rewrite this a little bit with this rational exponent, but otherwise, this is a perfectly fine answer. Let's do one more. This one starts a little bit different. So here, I'm going to be taking the derivative of a cubed root. So the first thing, and the thing that is important to remember, is a square root, a cubed root. The nth root, we can rewrite that as a rational exponent. So instead of writing this as the cubed root, I'm going to think about this as my expression, x to the 4th minus 3x plus 5. And I'm going to think about this as the 1/3 power. And written like this, now I can use my power rule for functions. So let's see what we end up with. So the 1/3 comes down out front, and we'll multiply by our expression, x to the 4th minus 3x plus 5, and subtracting 1 away from the exponent, so 1/3 minus 1, we're going to end up with a negative 2/3 power. And now we need to multiply by the derivative of the inside. So now using our power rule, derivative of x to the 4th is 4x cubed, and the derivative of negative 3x is minus 3. Now in this case, we will do a little bit of rewriting. So instead of that negative exponent, let's move that down into the denominator. And I do have a fraction of 1/3 here, so the 3 will also be in the denominator. So I have 4x cubed minus 3 in my numerator. And then the denominator of this fraction, we have our 3 from our 1/3. And then we'll put x to the 4th minus 3x plus 5 to the positive 2/3 power. So the power rule for functions is an extension of the chain rule. And as we can see here, it does work with any exponents, including exponents that are fractions.